Hello again, my chemistry ladies and gentlemen. So we are doing extra practice problems from the back of the book, and we are up to Module 12, number 6. It says, what is the volume of 12.1 grams of nitrogen gas at STP, standard temperature and pressure? So, number 6, we are looking for the volume of nitrogen gas. Now don't forget that nitrogen is one of those homonuclear diatomics, so it's always N2. And what do we know? We know that it is at standard temperature and pressure. Standard temperature is 0 degrees Celsius or 273 Kelvin. Standard pressure is 1.00 atmospheres. And then what else do we know from the problem? We know how many grams of nitrogen that there are, which means we can figure out how many moles of nitrogen gas there are. So let's do that first. 12.1 grams of nitrogen gas. See, this is where it becomes important to write down N2. We're going to multiply it by 1 mole of N2, which the mass would be 14.0 for one nitrogen and 14.0 for another nitrogen. So we've got 28.0 grams in 1 mole of N2. If you do that division there, you end up with 0.432 moles of N2. So now we know little n, which is 0.432 moles. And anything else that we know? Yes, of course, we always know the constant R, right? And so this time we can see pretty easily that we're going to be using this ideal gas law, PV equals nRT. PV equals nRT. We're solving for volume, so we're going to divide both sides by the pressure. So volume will equal N times R times T divided by pressure. And now we just plug in the numbers. So N is 0.432. We're going to multiply that times R, the constant, which is 0.0821 liters times atmospheres over moles times Kelvin. Don't tell, but I'm not actually going to write the units in the interest of time and space. And then we're multiplying it by temperature, which is 273 Kelvin. All right, all that over pressure, which is 1.00 atmospheres. So the volume of the nitrogen gas would be, after you multiply that and divide it by 1, 9.68, and your units would be liters, because, of course, that constant R has liters in it. Did I say that? I think I did. Okay. All right, so that's the answer for number 6. Moving right along, let's do number 7. Number 7 says, what is the pressure of 5.0 grams of nitrogen gas when the temperature is 21.0 degrees Celsius and the gas occupies 1.00 liter of space? Okay, so in number 7, we're looking for the pressure of what kind of gas? Nitrogen gas again. Oh no, here comes a little helper. We're gonna try to go quickly. What, Natty?
Okay. So can you put my other shoe?
Okay, can you just wait for Mommy a minute? Okay, what do we know? We know that the volume equals 1.00 liters. We know that the temperature equals 21 degrees Celsius. We add 273 and we get 294. Oh, this was 21.0 Celsius, so we can go to the tenths here for significant figures. So for our Kelvin, we'll have 294.2 Kelvin. That's volume, that's temperature. Do we know anything else from the problem? Yes, we know that we have 5.0 grams of nitrogen gas, which means we can figure out the moles. So we're gonna know N, okay? N equals, let's figure it out, 5.0 grams of nitrogen gas times 1 mole of N2 divided by 1 mole of N2 has a mass of 28.0 grams of N2. So if you do 5 divided by 28, we get 0.18 moles. So that would be what N is equal to, the number of moles, okay? 0.18 moles. Okay, so we're looking for P, we have V, we have T, we have N. Of course we have capital R because that's that constant that we know. Here, I'll write it in. R equals 0.0821, and that is liters times atmospheres all over moles times Kelvin. There, I'll write it in right there, and then I probably won't write it in later in the problem. And we're solving for P here, pressure. So we've got PV equals nRT. We're going to solve for V, so we're going to divide both sides by V. We're solving for P. Did I say that? PV. I start talking fast and I start to confuse myself. The V's shall cancel out. And so P will equal nRT divided by V. So we've got 0.18 moles for N times R is 0.0821 times temperature is 294.2 Kelvin divided by the volume, which was, yes, I did write that down, 1.00 L. Honey, you can get down. You're only like 3 inches off of the ground. There you go. Oh, don't be scared. Get down. Okay, get down. Mommy's got to finish this real quick. Okay? All right. So if we plug all those in, the pressure of the nitrogen gas will be 4.3 atmospheres. And that's how you solve for number 7. I was going to go on to number 8, but I think it's probably best if I pause for now. So I'll be back later with more. Bye-bye.
Mom,
What, darling?
after your video, can you make this for me?
Sure. After my video, I can make that with you.